Hello students, and this is Arjun sir, and today we are going to discuss about surface chemistry, NCERT based, and what questions we will expect from the NEET point of view. And now here in the surface chemistry, you know, it is the branch of science which deals about what are the reactions or takes place at the surface of any solid materials. Now here, so in this case, the first concept is adsorption. So you know, in the adsorption, it is surface phenomena. So now in this adsorption process, so either gaseous molecules or any liquid molecules which are concentrated or accumulated over the surface of a solid material. Now in this adsorption process, we have the two important components we have. The first one is adsorbate and second one is adsorbent. You know what is the meaning of adsorbate? So the molecules which are adsorbed over the surface of another material, and adsorbent means the surface on which adsorption takes place. For example, in case you take and here water vapors and also silica gel. In this case, and silica gel act as adsorbent and water vapors and behave as adsorbate, right? So for example, in this case, and this is one cube in case you take solid cube. Now here this is the NS, meaning is surface molecules, and NB bulky molecules. In the adsorption, the molecules which are accumulated only over the surface of solid material. So that is the NS. Now here NB is equal to 0. In this process, no bulk molecules are present. So that's why here NS, surface molecules only present, no bulk molecules. And coming to the absorption, and it is bulk phenomena. In this case, what happened? So the adsorbate molecules which are, and now here uniformly distributed throughout the solid material. So now here uniformly distributed means it is present in the bulk, and also one more is the here surface also. So that's why in this process NS is equal to NB. Understand? Now for example, here you take H2O vapors adsorbed by the anhydrous calcium chloride. So in this absorption takes place. Same concept here, H2O vapors, but we have taken here material is silica gel. Clear? Right. Now coming to the sorption. In this sorption, what happened? So simultaneously both adsorption and also absorption both takes place. But in this you have to remember, in the sorption process, the molecules present inside a bulk medium are the same time surface. But now here, and both molecules not equal to each other. But in the absorption, and both molecules, surface and also one more is, and bulk molecules, both are the same. Clear? Yes. Now coming to the desorption. You know desorption means opposite to adsorption. Now here, the removal of water vapors from surface of solid material with the help of heating or by any applying decreasing the pressure. So that is we consider as desorption concept. Now coming to the mechanism. So how adsorption takes place? You know, and this is the solid material in case you take, this is the solid material. So in this, what happened? We have the two important molecules we have. One is surface molecule and one more is bulk molecule. The surface molecule which experienced some residue forces because due to the presence of unbalanced attractive forces. But bulk molecule, it does not possess any residual forces. Reason also you know, and here these bulk molecules in all the directions, what happened? It will attract but in opposite direction with same extent. So that's why. So and here the surface molecule, and it will experience some residual forces. Due to these residual forces, these surface molecules are present in unstable state. That's why, and it will attract the surrounding molecules. So that's why, and whenever these particles, and this is adsorbate particles, understand, whenever these adsorbate particles are adsorbed over the surface, automatically what happened? Some energy released. So that's why adsorption process is always exothermic process. That's why I have taken here delta H is equal to negative. Any adsorption, either physical or chemical, whatever it may be, adsorption process is exothermic process. Next, after adsorption, so adsorbate randomness what happened? Decreases, because that molecules are accumulated over the surface. That's why delta S is equal to negative. You know, it will determine the randomness of the material. Now, and here adsorption process is, it is spontaneous process. You know, for thermodynamic property, for any spontaneous process, delta G is equal to what? Negative. So that's why, and any adsorption, delta H is equal to negative, delta S negative, delta G also negative. That is. Next, coming to the types of adsorption. In these types of adsorption, we have the two. One is the physical adsorption and one more is chemical adsorption. Actually, this classification did based on the forces operating between the adsorbate and adsorbent. In the case of physical adsorption, van der Waals forces are operating. In the case of chemical adsorption, chemical forces are operating. Now, this is not specific, means on any solid material, physical adsorption takes place. Like that, chemical adsorption not. So because, and if between the adsorbate and adsorbent, if chemical reaction takes place, then chemisorption possible. That's why it is highly specific. Next, and which, and here the physical adsorption depends upon the nature of the gases, means easily liquefiable gases highly adsorbed. You know, those gases has high critical temperature, has the and easily adsorbable gases. Now in this case, and those gases which can react with the adsorbent, in that conditions only what happened? Chemisorption possible. Here highly liquefiable gases, here those gases can react with the adsorbent. Next, and physical adsorption. You know, physical forces are weak forces. Now in this, less amount of energy only released. How much here? 20 to 40 kilojoules per mole. I told here. So in this adsorption process, what happened? Surface energy, the energy possessed by surface molecule, lose in the form of heat. That is the delta H is equal to negative. Same here, 20 to 40 kilojoules per mole. But in the chemical adsorption, 90 to 240 kilojoules per mole energy is released. Now here physical adsorption, low temperature is favorable. You know, according to Le-Chatelier principle, for exothermic reaction, so we want to go in further forward direction, the low temperature is the favorable. Now in this case, high temperature. So you know, in the chemical adsorption, any chemical reaction want to do, and compulsory that reactant molecule which must possess some minimum amount of energy. You know that energy is also called as threshold energy. Clear? Same here also, and high temperature. Whenever temperature increases, automatically the reactant molecules and speed what happen? Increases. Now here, in this case, no activation energy is needed. But in this case, high activation energy possessed by what? Reactant molecule. So that's why we should increase the temperature. Correct? Now, in the physical adsorption, what happened? Multi-molecular layer it will form. But in the chemical adsorption, unimolecular layer it will form. So only one layer only it will form here. The multi-layer it will form here. Next two. And both physical adsorption and also chemical adsorption depends upon what? Surface area. Clear? Now in this case, we have the two important graphs we have regarding to the physical adsorption and also chemical adsorption. So regarding to the physical adsorption, now here, so in the physical adsorption, so graph is, so here, whenever we will draw the graph between x by m versus, and one more is the temperature. So what happened here? So like this. Sorry. Now in this case, yes. Right. So now in this case, whenever we will take the pressure. Right. So now in the case of, and this one, x by m versus, and here, and temperature in case you take, what happened in the case of chemical adsorption, here chemical adsorption in case you take, and this is first increases, again what happened here? Decreases. This is the, in the case of chemical adsorption. Now, and physical adsorption in case you take here, x by m versus temperature in case you take, x by m versus temperature in case you take, what happened here? So temperature increases, it is continuously what happened? Decreases. And this is pressure and this is the temperature concept. Now, after completion of this one, the next one is Friendly's adsorption isotherm. Means this adsorption isotherm, it will explain about the, which one? Effect of pressure on adsorption concept. So now the Friendly scientist, he given as one mathematical relation, that is x by m is equal to k into p to the power of 1 by n. So now here, what is the meaning of n here? The n values always greater than 1 and 1 by n values which is present in between the 0 less than 1 by n less than 1. So now whenever we will take the x by m versus pressure in case we take, here what happened here? At a different temperature I have taken. So temperature increases, adsorption concept, what happened here? Adsorption value decreases. You see here 193 Kelvin, at low temperature what happened? Adsorption is very high. Understand? Now in this case, log x by m versus log p, in case we take in this case also, sorry, now here, so now here x by m versus one more is the, and p in case we take here. So now here also 1 by n is equal to 1, and here at high pressure conditions what happened? So adsorption is what happened here? Constant. At low pressure, x by m is directly proportional to what? Pressure. At intermediate pressure, 0 less than 1 by n less than 1, means this 1 by n value which is present in the fractional value. And one more is, in case we take the log x by m is equal to log k plus 1 by n log p. 1 by n log p in case we take, here also in case we take here log x by m versus one more is the log p in case we take. So this is the straight line equation and we have the positive slope also, and we will get the, so this is the slope of this one, and here, and slope is equal to how much here? 1 by n. Slope is 1 by n and intercept value is what? Log k. And this is the simple information regarding to the adsorption concept. Clear? So thank you. Hello students. Welcome back. The last lecture we discussed about the adsorption concept, and now we are going to discuss about, and one more very important topic is catalysis concept. In this we know the catalyst, it is nothing but the substance which may increase or decrease the speed of chemical reaction. So in this, and potassium chloride on heating around 473 32633 and 2 KCl and also 3 O2, potassium chloride and also oxygen. But now here catalyst is MnO2 used as catalyst. But whenever in the options of MnO2, we should maintain the high temperature around 650 Kelvin to around 800 Kelvin temperature is required to accelerate this reaction. So now here the next one is the types of catalyst. Now this classification based on physical state of reactants and catalyst. So here the first one is homogeneous catalysis and second one is heterogeneous catalysis. In the homogeneous catalysis, the reactants and catalyst both are present in the same phase. In the heterogeneous catalysis, reactants and catalyst and both are present in different phases. The next one more classification. So here the positive catalysis, negative catalysis, autocatalysis, induced catalysis. Regarding to the positive catalysis means the substance which increase the speed of chemical reaction by decreasing the activation energy of reactants. For example, here SO2 plus O2 gives rise to 2SO3. Now here this platinum act as positive catalyst. Now this platinum and which increase the speed of chemical reaction by decreasing the activation energy of reactants. In the negative catalysis and decomposition of H2O2. In this decomposition process, acetonylate or phosphoric acid or one more is the glycerol we used as negative catalyst. This negative catalyst which decrease the speed of chemical reaction by increasing the activation energy of reactant molecules. Now and one more is oxidation of chloroform into phosgene COCl2. Now in this case we used as alcohol as negative catalyst. Now the one more is autocatalysis, and in this reaction we don't need any external catalyst. So in this case one of the product only behave as catalyst, and ethyl acetate undergo acetic hydrolysis produces acetic acid. Now here this reaction basically initially it goes very slowly, but after the some time the speed of chemical reaction increases. Reason you know here, acetic acid initially the less it will, initially not it is there, but once the reaction it will proceed, what happened here, acetic acid it will form. Once it will form, what happened, the speed of chemical reaction increases, because now here the acetic acid behave as autocatalyst or self-catalyst. Now coming to the induced catalysis. Induced catalysis means some chemical reactions it will not complete, it will not done in the itself, but in the presence of another reaction takes place. So for example, oxidation of sodium arsenate does not take place, but in the presence of oxidation of sodium sulfide this reaction takes place. Such type of catalysis reactions are called as induced catalysis. And coming to the promoters and also poison. What is the meaning of promoters? You know, it will increase the activity of catalyst, and poison it will decrease the activity of catalyst. Example, in Haber process molybdenum we used as a promoter. In the Haber's process and carbon monoxide and hydrogen sulfide we used as poison. In the contact process also arsenic oxide we used as poison. Coming to the characteristics of catalyst. Now in this case the first one is it remains unchanged, and chemical composition and one more is and quantitatively also remains unchanged. The next one is it's a small quantity is enough, and third one cannot initiate the reaction, and fourth one is cannot change equilibrium position, and it will work effectively at optimum temperature only. And coming to the mechanism, actually we have the three important mechanisms we have. Among that one major important one is modern adsorption theory. So actually this modern adsorption theory is a combination of old adsorption theory and intermediate compound formation theory. So intermediate compound formation theory, it will explain only about the homogeneous catalysis, and modern adsorption theory, it will explain about heterogeneous catalysis. And in this adsorption mechanism concept, we have main 5 important points we have. The first one is diffusion of reactants. Second one is adsorption of reactants. After adsorption, what happened? Chemical reaction takes place, that is formation of intermediate compound. And the next one is desorption of product. And last one is diffusion of product. These all are 5 important points takes place in the concept of mechanism of modern adsorption theory. After completion of this one, the next activity. What is the meaning of activity? The ability of catalyst which accelerate the speed of chemical reaction. This activity and possessed by group 5th to 11th group. But among these, effectiveness it is present by 7 to 9 group element. Next, coming to the selectivity concept. Regarding to the selectivity, and means now here, once you change the catalyst, automatically the products also change. You see in this case, the reactants are same. But here, once you change the here nickel catalyst, here copper, zinc oxide and also chromium oxide, here copper. Once you change, automatically products also change. Next, shape selective catalysis. Actually, these reactions depends upon the pore size structure of catalyst and the size of reactants and also products. The best example shape selective catalyst is zeolites. So the zeolites are 3D covalent network structure and 3D covalent aluminosilicates. So in this, some silicon atoms are replaced by what? Aluminium. It will give the important aluminum oxygen silicon framework it will produce. So the best example for and this one shape selective catalysis is ZSM5. So in this case, and alcohol it will convert into the gasoline by dehydration process. Clear? Yes. Now coming to the enzyme catalysis. It is nothing but the biocatalyst. And we can say it is organic catalyst also. So now in this case, the sucrose is converted into the glucose and also fructose in the presence of invertase as enzyme. Starch is converted into the maltose in the presence of diastase. Glucose is converted into ethyl alcohol in the presence of gymnase. And the urea converted into ammonia in the presence of urase as enzyme. And milk is converted into the curd in the presence of lactobacillus. And proteins are converted into the peptides in the presence of pepsin as enzyme. Next, proteins are converted into the amino acids in the presence of trypsin as catalyst. Now finally coming to the characteristics of enzymes. So in this, it is highly efficiency. Enzyme catalyst also highly efficiency, just like inorganic catalyst. Next, this one also, the small quantity is enough and highly specific. For example, now here, in the sucrose is converting the glucose and fructose, invertase is only suitable, not the diastase and also gymnase. And these enzymes work effectively at optimum temperature, that is 298 to 310 Kelvin, and optimum pH also 5 to 7. And these enzymes also we can activate it by either activators and one more is the coenzymes. Basically, we can use activators as metal cations like sodium cation, potassium cation, like the cobalt cation. Same like that. And enzymes also, enzymes activity we can decrease it by in the presence of inhibitors and also poisons. Clear? So this is the simple information regarding to the catalysis concept. So thank you. If you like this video, please subscribe my channel please. Thank you one and all.